Today we're going to be talking about section 2.3, which is on graphing equations of lines. And our goal is to graph linear equations in slope-intercept form or standard form. So we're going to talk first about a parent function, and that's the most basic function in a family of functions. And then the y-intercept is the y-coordinate of point where the graph intersects the y-axis. Now, most of what we've done, what we're going to do here in this section, you've already looked at in Algebra 1, so it's going to be a quick review of some of the things you learned. Now, remember, when we're graphing, you can always, no matter what your equation looks like, make a table of values. So if you ever have a question on a quiz, on a test, on any assessment that you ever have to do and you're not sure how to graph it, make a table of values. Plug in a value for x, and then also figure out what y is after you plug that in. So you can make a table of values. And you can do that on these problems if you'd like to. Now when we talk about the parent function for a linear equation, it's y equals x. Slope is 1, y-intercept is 0. So if we would graph that, it would look like this. This is the parent function of all linear equations. And so I'm going to put that on both of these graphs because the directions tell us that we're going to compare these equations that we draw with that. So our goal here is to graph this equation. Well, remember, it's y equals mx plus b. M is your slope, and b is your y-intercept. So in this case, slope is -2, y-intercept is 0 because it's plus 0, there's nothing there. So we're going to graph that. So y-intercept is at 0, it's right there. Slope is -2, and we can write that as a fraction -2 over 1, which means we go down 2 over 1, down 2 over 1. We could also go up the other way. So there's the equation of our line. So now it says compare it with the parent function, which is y equals x. So we're going to say it has the same y-intercept as the parent function, but this one has a slope of -2 instead of a slope of 1. So those are the things you're going to have to write down for comparing it. In example B, again, we want to find the slope and the y-intercept. Let me erase this so we have some room. So m equals 1 and b equals -1. So slope is 1, which means I could write that as 1 over 1. If I write it as a fraction, that means up 1 over 1, up 1 over 1, up 1 over 1. So our graph is going to look like this. So now if we would compare this one to the parent function, we're always going to compare the two things, the slope and the y-intercepts. Okay? So in this case, we're going to say, well, this function or equation has a y-intercept of -1 instead of 0, but they do have the same slope. They have the same slope, and that slope is 1. And so here, when we look down below, we're talking about the slope-intercept form, and that is the equation y equals mx plus b, where m is the slope and b is the y-intercept. And again, if you don't know that equation, make sure it gets on your note card because you're going to need it. So we already just talked about how to use slope-intercept form to graph it, but there is the step-by-step process. Write the equation in slope-intercept form. So you want to get y by itself, y equals something. And that's why we've done some of those other problems that we did in section 1.4 and 1.5 where we solve for the variable. We're going to identify the y-intercept, which is b, and use it to plot the point 0b where the line crosses the y-axis. Then find the slope and use that to find your second point, and then draw a line through there. So once again, example 2, we're going to graph this. So slope is 3/4, y-intercept is -2. Put those on here. So we're going to go, our y-intercept is here at -2. The slope is 3/4, which means the rise over the run. So I'm going to go up 3, 1, 2, 3, over 1, 2, 3, 4. There's my graph. And so that's really all you need to do to graph in slope-intercept form. So there are 9 problems here on the guided practice. Go ahead and graph a few of them. You don't have to do all of them, but graph a couple of them that are a little bit different, and then we'll see what they look like. So go ahead and pause the video, and you can hit play when you're ready to move on. So here are the answers to each of these guided practice. Now remember also, and I didn't write this down here, but you also have to compare them with the parent function. So in example 1, you'd say they have the same y-intercept, but this graph has a slope of -2 instead of 1. Number 2, this graph, they have the same slope, but this one has a y-intercept of -2 instead of 0. And on and on. And then if we'd get down to a question like number 5, we'd say, okay, this one has a y-intercept of 4 instead of 0, and it has a slope instead of 2/5 instead of 1. So both the slope and the y-intercept are different in this case. And then if we jump down to questions 7, 8, and 9, notice they're in function notation, and even 7 as well. But I switched them to put them into slope-intercept form. So my x is first. I'll always write those in that way, so it's in mx plus b form. That way it's easier to find your slope and your y-intercept. And notice number 9 as well, that I graphed it. My graph went off the chart. If you wanted to switch those and go by 2's on your graph, you could do that as well. So that's graphing in slope-intercept form. Example 3 is now a multi-step problem. It says a value y of copier X years after its purchase can be modeled by this equation. Y equals $4,000 minus 600x. Graph the equation, describe what the y-intercept and the slope represent in this situation, and then use a graph to estimate the value of the copier in 5 years. So the first thing that we're going to do is we're going to change a graph here. I'm going to make this the origin 0, 0. And so we're looking for 5 years. We'll go by ones on the years. So this is 1 year, 2, 3, 4, 5, 6, 7, 8. And I'm going to switch the y spaces, or the y coordinates, and we're going to go by, well, we need to get up to at least 4,000 because we know that the copier is going to cost that. So we'll go by 500. So I'm going to go 1,000 here, 2,000 here, 3,000 here, and 4,000 here. So again, M, B. M is -600. B is 4,000. So we're going to graph that. So at 0, it is 4,000. That's my y-intercept. So now I'm going to go down 600. So down 600 and over 1 would give me right about there. So down 600 and over 1 is going to give me there. Down 600 and over 1. And I'm going to keep doing that. So I'm going to take our graph. And we're going to look at it there. So describe what the y-intercept and the slope represent in this situation, and then use a graph to estimate the value of the copier in 5 years. Well, the slope, it says -600. Remember, x is the number of years. So the slope is telling us how much this decreases. So it's the price decrease per year. So how much less does the copier cost every year? And then the y-intercept is telling us what is the starting value. So the original price of the copy machine. So now once we have the graph, we can look here and say, okay, right there is where it's at in 5 years. So it looks like, according to my graph, we're going to be at $1,000. So the value of the copier is going to be worth $1,000 in 5 years. So it started at 4,000 and it's going to be worth 1,000. Well, let's see how accurate that is, because we're always going to have a little play in our graph when we draw them. So we could do that by also putting in 5. Well, 600 times 5 is 3,000. 4,000 minus 3,000 is 1,000. So our graph is pretty darn accurate. Now, notice here again, if we look at this, I probably need to move this so it's here, because my graph will never go below this line, the x-axis, because I can't really have a negative amount there, and it won't go past that. So it's going to be in quadrant 1 or on that x-axis or y-axis. Reason being is we're not going to have the value of a copier before year 0, before it was made, and we're never going to go into the negative amount of money. The next thing we're going to look at is standard form of a linear equation. And again, if this is an equation that you need on your note card, make sure to get it there. Okay, and it's ax plus by equals c. So you're going to have your x and your y on the same side, where a and b are not both 0. Now the x-intercept, we've talked about the y-intercept already. That's the point where the graph crosses the y-axis. The x-intercept is the point where the graph crosses the x-intercept, or the x-axis. So when we look at using standard form to graph an equation, you can do it one of 2 ways. You can do it using the cover-up method, which we're going to talk about, or you can always switch it to slope-intercept form. If you switch it to slope-intercept form, then you would graph it exactly the same. So what we're going to do is we're going to do this equation both ways. Using standard form to graph the equation, step 1 says write the equation in standard form. Okay. If we look at example 4, done. It's in standard form. X and y are on the same side, the constant's on the other side. Identify the x-intercept by letting y equals 0 and solving for x. Use the x-intercept to plot the point where the line crosses the x-axis. All right, so that's what we're going to do right now. Identify the x-intercept. So cover that up. That's 0. And that's what they say. Put in 0. Solve for x. Well, x-intercept is -3. 6 divided by -2 is -3. So my x-intercept is -3. Now we're going to do the same thing. Step 3 says identify the y-intercept by letting x equals 0 and solve for y. Use the y-intercept to plot the point. So now we're going to do the same thing. Cover up the x. That's 0. So my y-intercept, solve it. 6 divided by -3 is -2. My y-intercept's -2. Draw my line. That was step 4, and we're done. So that's how you can do a problem if it's in standard form by solving it. Well, the other way to do this is to use slope-intercept form. So if we would do that, let's take the equation and let's solve it for y. So we're going to have -3y equals 2x plus 6. We added the 2x to both sides. Now we divide by -3. So we're going to get y equals -2/3 x minus 2. And then notice here, the y-intercept is -2, and the slope is -2/3. So here is my y-intercept at -2. I'd go down 2 over 3, right there. So we're going to get the exact same answer. Next, we're going to talk about horizontal and vertical lines. And this is something that a lot of students struggle with, remembering which one is which. So if you need to know that, write it on your note card, help you out. So the horizontal line is y equals any number. Okay? Y equals any number. So if I have y equals 3, it's a horizontal line through 3. I have y equals -7, it's a horizontal line through -7. All right, so vertical lines then will be x equals some number. And that is this one. Okay, if you have x equals 4, it's a vertical line through 4. You have x equals -6. It's a vertical line through -6. So if we look at this, -3, y equals -3. Where does y equal -3? Well, here is y equal -3, and it is every point on that line. Because think about it this way. What's that ordered pair? -4, -3. What's this ordered pair? 0, -3. What's this ordered pair? 3, -3. So no matter where you are at on that line, your y value is going to be -3. Then we're going to come over here, and x equals 4. So 4 went off my graph apparently. So here is 4. So I'm going to draw my vertical line, because this is the ordered pair 4, 0. This is the ordered pair 4, 5. This is the ordered pair 4, -2. So no matter what, my x value is going to equal 4. So if it's y equals just some number, it is a horizontal line. If it's x equals some number, it is a vertical line. All right, so now we're going to jump down to some guided practice questions. I want you to do questions 11 through 14. Graph those quickly. You can use either slope-intercept form or the cover-up method for 11 and 12. And then just graph those vertical and horizontal lines in 13 and 14. So go ahead and pause the video, and you can hit play when you're ready to move on. And here are the answers to the guided practice questions. Now, section 2.3 is a recap. We're talking about graphing equations of lines. All right, we looked at graphing them if they're in slope-intercept form, which is y equals mx plus b. We talked about graphing them if they're in standard form, which is ax plus by equals c. Make sure you know both of those. Also, we talked about graphing vertical and horizontal lines, and then how to compare graphs with the parent function. So your homework assignment for section 2.3 is below. It's on page 93.